Okay, here we go. 12.2 Arithmetic Sequences Day 2. So today we take our basic understanding of arithmetic sequences from yesterday, that there's a common difference, and we use it to now write a general rule. How could we find the nth term, or use that to find a specific term like a sub 15, the 15th term. So we take our first sequence today, 4, 9, 14, 19, and clearly it's arithmetic. It's got that plus 5, plus 5. There's a common difference of 5 here. But what we want to know is like the 15th term. And sure, if this is the first term, second term, third, fourth, we could keep going, up by 5, keep it going till we find the 15th term, but that might take a while. And even if you think of other ways you could do it, it helps to have a generalized form for the nth term. So if it's not just about the 15th, if we wanted the 8th term, the 30th term, the 132nd term, we'd have one way that would work all the time. So let's go ahead and get started. The first way we're going to see how to do this is to put our information in a table. Now I'm going to call this an n a sub n table. Now think about how we're working on sequences and how this is like an xy table. In a sequence, the x values, the domain, are the term numbers. So this is term number 1, 2, 3, 4. Term number 1, 2, 3, 4. And again, those are the n values. They're also like my x values. They're the domain of this problem. So then in a sequence, the range, the y values, they're the actual sequence numbers. A sub 1 is 4. And then a sub 2 is 9. And so on with 14 and 19. Well then, what I'm really after is the nth term. I don't just want the 5th term, 6th term in order. I want to see how can I make a jump and find any term I want. The nth term, and that would be a sub n. So the first thing we're going to look at here is kind of where did these numbers come from? Starting with the first number, the 4, well, where did that come from? It just sort of came from itself. It's the beginning of the sequence. You have to have a starting number somewhere. But as for the next number, well, when we saw that this had a common difference of plus 5, then instead of thinking of this as the number 9, I'm going to see it as 4 plus 5. And then if I think about the 14, I know that that's another plus 5. Now, I'm not even going to just see this as 9 plus 5. I'm going to bring it back to the beginning. It was a 4, and then we did plus 5 and plus 5 again. So finally, by the time I get to the 19, and I've done plus 5 again, I can see that as starting with 4, and then I did plus 5 1, 2, 3 times. So plus 5, 1, 2, 3 times. Now, just the way I said that last one, that I added 5 3 times, makes me think there's a shorter way to write this. I can write this as 4 plus 5 times 3. I added 5 3 times. Well, now if I go up to the line above that, I can rewrite this as 4 plus 5 times 2. And above that, it's 4 plus 5, and it looks like that time I only added it once. And in fact, this top one where we didn't see a plus 5, even that can be written this way. It was 4 plus 5, and we did it 0 times. Now, the reason I did all this is now I can start to see kind of a pattern or a structure in how did I find each number, and that's going to help me make a general one. Like, look at all of these expressions here. They all started with the number 4. So I know that if I want to find any term at all, I'm going to start with the number 4. And then they all had a plus 5 right here. So I know that no matter what I'm going to do, I'm going to start with 4, and then I'm going to add 5. The trick was really, but how many times did we add 5? And we want to see if we can relate that to the term number. So when I see that the 4th term used 5 3 times, the 3rd term used it twice, the 2nd term used it once, I notice it's always 1 less than the term number, that when I had term number 4, 4 minus 1, I used it 3 times. There's the 1, 2, 3. To get from 1 to 4, you can think of it like that. And so if I want the nth term now, since it's always 1 less, I'm going to use the number 5 n minus 1 times. And this is the general form of the nth term. A sub n is 4 plus 5 times parentheses n minus 1. Now, using distributive property, etc., that can be simplified. You could write it, if I see this as 5 times n, that's 5n. and then that would be 5 times negative 1 was negative 5, but there was also a 4 here, so like 5n minus 1. You could work that out and see that these are equivalent. So this is kind of the form I get by following the pattern. This is a simplified form, and now I can use this to easily find a sub 15. So now if I want the 15th term, a sub 15, I'm going to do 4 plus 5 times 15 minus 1. Or I could have used this one as well, of course. Either way shouldn't matter. You get an answer of 74. That's 15 minus 1 is 14, 5 times 14 is 70, and 4 plus 70 is 74. So then let's go ahead and look at one more for today. This is our next sequence, 60, 52, 44, 36. And I'm going to go a little quicker through this one, but I'm basically going to do all the same stuff. I'm going to make an A sub n and n table, where n is like the x values, the term numbers, a sub n is like the y values. I've got terms 1, 2, 3, and 4, and I want to jump and see if I can find term n. So I've got the first term was 60, then 52, then 44, then 36. I want to make that jump to a sub n, and I'm going to show where did each of these numbers come from. 60 was the starting value for this sequence, and then from there it went down by 8. So that's 60 minus 8, and then down by 8 again, 60 minus 8 and minus 8 again, and finally by that last one it went down by 8 1, 2, 3 times. Start at 60, go down by 8 1, 2, 3 times. Rewrite that as 60 minus 8 times 3, or above there was 60 minus 8 times 2, 60 minus 8 times 1, and even 60 minus 8 times 0, and then I can see a sub n, the general one, always started with 60, always went down by 8, and we just had to see, but how many times did it go down? And the fourth term went down 3 times, it's 1 less again, so the nth term goes down n minus 1 times. And that's an answer for that problem. Or, just like before, we could simplify it. Another way to write it, if I distribute the negative 8n, and then the negative times negative would make positive 8, 60 and positive 8 is 68. So there's another answer for that one, and then I can use that to find a sub 15. 60 minus 8, n is 15. And if you put a 15 in right there, you can evaluate that. You should get an answer of negative 52. If you kept going down by 8 over and over, eventually the 15th term would be negative 52. So last thing to wrap up with here is kind of look for some connections between these two examples. Like when I look at my a sub n answer in the first sequence, and I look at my a sub n answer in the second sequence, I notice they're very similar to each other. So I'm going to write a general, here's something you can use for every problem now. A sub n is always. Well, the first sequence started with a 4, and where did that 4 come from? It was the first term. The second sequence started with a 60. Where did that 60 come from? It was the first term. So you're always going to start with the first term. And then after the 4, we did a plus 5. Well, why plus 5? It was the common difference. And after the 60, we did a minus 8. And minus 8 was the common difference. So after the first term, you always use the common difference. Now I put plus d, but if the common difference is negative, like negative 8, then that could be a minus d. Okay, so plus d. Now the last bit remains is how many times did we use the common difference, and that in fact was always n minus 1, n minus 1. So in general, for any of these problems, you could take the first term, 60, drop it in right there, take the common difference, negative 8, drop it in right there, and 60 minus 8 times n minus 1, that's exactly the same answer we got before. So a much quicker kind of shortcut way here. And then last thing to note is when I simplified them, you might have noticed that the simplified answers looked like slope-intercept. So there's another way that we could get these answers if we think about slope-intercept form. You'll notice that the slope, 5, came from the common difference. And that's the slope, negative 8, came from the common difference. So as for the what is like the y-intercept, 68 or negative 1, well technically y-intercepts happen when x is 0. Now these sequences, they don't have an x value of 0 because we start with the first term. So it's kind of like pretend or make-believe, but if there was a 0 term up there, well, then if this was plus 5 going down, it would be minus 5 to get back up. And 4 minus 5 is negative 1. So there's a y-intercept of negative 1. Now again, that doesn't really exist. There isn't a 0 term. Sequences start with a first term, but this is just a way that it could help us find the value that belongs right there. You'll notice it works again right here. If you wanted to write the simplified form faster, you'd use your common difference of negative 8 as the slope, and you'd find your y-intercept by going up to a 0 term, which means if this was minus 8 going down, you're going to do a plus 8 to get back up. And 60 plus 8 is 68. So in the end, ultimately, we've got like 3 ways we could find these answers. You could go what I'll call the long way and actually use the table and write it all out. It's great. It really shows us why this works the way it does, but it also takes a while. So you're also welcome to use the formula down here, kind of like a shortcut version of what we did in the tables. Or if you want to get the simplified answer, you're also welcome to kind of back up on the table and use that imaginary 0 term, what would be the y-intercept. And they all 3 should work. Go ahead and work on your assignment today from page 806. Thank you very much.